Welcome back to Reconstructing Gravity. This is Chapter 6 called Inertia versus Gravity. And in this chapter, we're going to look at why gravitational mass is always exactly proportional to inertial mass. There's a relationship between inertia and gravitation. And with our constructive model, the answer to this question will become extremely clear. No doubts about it. Remember, it's not simply the motion of space past the mass that causes the mass to accelerate. Here's our special relativity model again with energy cycling inside a particle of mass. And in this case, we have the downward speed of space past the mass is downward in this picture. But with the space velocity being uniform, there's no acceleration. Particle just keeps humming along in harmony at the same speed. As we saw in the last video called ball drop, it's the space that has a velocity gradient increasing downward which causes mass to accelerate. The higher relative speed of space in the lower half of the particle causes an ongoing perpetual offset in the point of harmonious return. But let's consider what's happening inside a mass that is not accelerating, even though it is in a gravitational field where there is a downward space velocity gradient. Obviously, this is a mass that's just sitting on the ground or is otherwise held from falling. But how does a non-falling mass in a gravitational field maintain its harmony of internal energy cycling? On the simplest level of analysis, the answer is fairly obvious. Here's what we had for the falling mass. The space velocity gradient would cause the energy cycle to end up in a new center below where it originally started. But the force that holds the mass up must create a strain gradient which counters this effect of the space velocity gradient. To keep the center of the particle from moving, the lower half of the particle must be shortened more than the upper half of the particle. This shortening of the lower half, compared to the upper half, would cause the energy to continue to return to the same place where it started. And what do I mean by strain gradient? Strain is a concept used in engineering, and I mean something similar here, but slightly different. Let me explain. If an object is squeezed by an equal force at both ends, it will get shorter. Strain is just the ratio of the change in length over the original length. And when in this kind of situation, it's called uniform strain. Every part of the bar will be compressed the same amount all the way down. But in a gravitational field, things are different. The upward force at the bottom of the object equals the weight of the object. But then we can imagine breaking the object into smaller parts. At the middle plane, the force or pressure is half of the total weight. Each part must be kept in equilibrium with balanced forces. And as we go higher, the pressure across any cross-section continues to get smaller. And the strain, the amount of compression in that region, also gets smaller. So this is a general picture for any mass that's not falling in a gravitational field. There's a pressure gradient and a strain gradient that goes with it. This description is what I'll call engineering strain. It has to do with the properties of the whole object. But I said I meant something slightly different here. That engineering strain refers to the bulk properties of the whole object. But now I want to discuss strain at the particle level. We can think of the bulk material as a matrix of relatively rigid particles separated and connected by a series of very squishy springs. The atoms and subparticles are far more rigid than the bulk material, but nonetheless, each particle will experience more upward force than downward force, the difference being its own weight. Though these particles may be quite rigid, they will still deform under pressure and will still have a strain gradient, just enough as required to counteract the effect of the downward velocity gradient of space. With this model of strain gradient balancing the effect of velocity gradient to normalize the energy cycling within particles, isn't it entirely obvious why inertial mass is always proportional to gravitational mass? If a space velocity gradient but no strain gradient causes downward acceleration g, and a space velocity gradient with strain gradient via force F has zero acceleration, then a strain gradient from the same force F without a space velocity gradient would cause the same acceleration g upwards, or horizontally if we put the thing on a frictionless surface. Without a physical model for how gravity works, it may be difficult to see how inertial mass and gravitational mass are related. But our constructive model relates them conceptually, without calculations or modeling of specific atomic structures. The key is the maintenance of equilibrium based on the basic constructive model of energy cycling within all mass particles. In the next video, I think we'll come back to work on the space flow model again. It's proven to work really well for explaining gravity, but it itself needs to be explained as to how that flow model can work. That's it for this time. Thanks for watching. Please like and subscribe if you enjoy this content. And remember, I've added a playlist tab on my YouTube homepage, so you can check out full-length tracks of all my outro music if you want. And I'll catch you next time.
When the world is wrong, better right yourself. It'll make the dark clouds fly. Nobody talk and put out the light. Just don't let the spirit die. If you never see the sun till 91, don't you never give up the fight. Sure be glad when you see the dawn. Somebody turns on the light. Somebody turns